go ahead and take a look at a couple of our homework problems here. I'm on problem number 2, section 9.1. The first question is, or the second question is, describe the range of values for the correlation coefficient. Keep in mind what the correlation coefficient range is. The range of the correlation coefficient is from -1 to +1. It can be anywhere from -1, which is a perfect negative, very, very perfect negative, or a +1, which is a perfect positive. It cannot be less than 1, -1, or greater than +1. So keep that in mind. All right. Okay. What about the next question? All right. Which values of R indicate a stronger correlation? So what I have here is I have two values. One is R 0.801. Remember what R stands for. R stands for correlation coefficient of a sample. And this is another correlation coefficient. So they're asking me, hey guys, which one's stronger? So when you look at it, if you look at in terms of positive and negative, definitely the positive value will be greater than the negative value. But for correlation coefficients, you don't look at the positive or you don't look at the negative. You only look at the value. So I'm going to take this 0.801, the absolute value. So this becomes a positive, and I will compare it to 0.866. So if I look at it, definitely 0.866 is greater. So what are you doing? You're taking the absolute values, so both of them become positive, and you compare. So 0.866 is greater. So that's why negative is a stronger, -0.866 is a stronger correlation. Remember, I'm only asking you, is it strong correlation? I'm not asking you if it's a strong positive or strong negative. So it's a strong correlation. So you only take the value, the absolute values. So when you look at it, 0.8 is greater than, so all right, all right. We will come back to this one later. Remember what explanatory variables are and what is a response variable. Your x value is your explanatory variable. Your y value is your response variable. So read the question and see what is depending on what. So your x is your independent and your y depends on your x. Okay? All right. Now let's go ahead and take a look at problem number 6. The accompanying table shows the ages of shows the ages of children and the number of words in the vocabulary. Complete part A through D below. Click here to view data table and click here to view critical values of Pearson correlation coefficient. So let's go ahead and look at the data table first. But let's go ahead and see what they're asking me here. They say, hey guys, I'm giving you a table of number of ages of the kids and the words that they speak during that age. So by default, you know that as the age increases, the vocabulary increases too. So definitely it's going to be going up, which is going to be a positive correlation. But let's take a look. It says click here for the table. So I'm clicking here for the table and the table pops up and I see ages 1, 2, 3, 4, 5, 6 different ages here. But what I'm going to do is I'm going to go ahead and open this in StatCrunch. So once you open the data in StatCrunch, this is your data. I'm just going to go ahead and sort the table. And this is all the information I have. My sample size is 11. I will go to stats and you will go to regression. I'm going to pause here, write this down. Stats, regression, simple linear. This is all where you will go for the entire chapter 9. Okay, stats, regression, and simple linear. Once you click, it's going to ask you what is your x variable. Age is independent. It clearly says age is x. So if you look at it here, it automatically tells you the age is x. Do you see that? And I'm going to move this. Vocabulary size is going to be y. So let me go ahead and move this to the side so y'all can see. Yeah. Yep. So my age is X because it clearly says X and the Y, it goes in Y. So if you flip-flop this or if you interchange these, your entire graph is going to be messed up. So the only thing you have to do is you're going to put your X in X, Y in Y. How do you do that? You will select, see, X, X and X, very good, Y and Y, and that's all you will do. And you will click compute, as easy as it looks. Okay, so now when you see, you will see all of this right here. There are a couple of things that you have to take into consideration. So once you get this table here, do you see correlation coefficient? Do you see something that says correlation coefficient, right? That's what you're looking at, correlation coefficient. So when they ask you for correlation coefficient, that's exactly what you will be looking into, the correlation coefficient. So the R value, oops, what did I do? Okay, the R value is your correlation. This is your correlation coefficient. All right. Okay, I am going to go ahead and go back here. The correlation coefficient in this case is 0.9768. So let's go back and see what we have. Okay. What are they asking us for? Where is my question here? They said, which one is my graph? So where do I find my graph? I'm going to go back to my StatCrunch. And if you look here, there are two arrows all the way in the bottom. There are two arrows all the way in the bottom here. Do you see this arrow? Yeah. So what you're going to do is you will go ahead and click on this arrow and it will give you a graph. You see that the graph is going all the way up. So it's a positive correlation. Do you see that? It's a positive correlation. So what I do is I go back here and see which one is it. So this is going down. Do you guys see this? This is going all the way down. This is going down. This is going up. And I have another one. This is also going up. Do you see that? Okay. But look very carefully here. Both of them are going up, but look at my ages. My ages are not in thousands. My ages are 0 to 48. So my option would be option C. So be very careful when you look at it. Probably they both look the same, but look at your x-axis. Your age is 0 to 468, not in thousands. Okay, so I'm going to go ahead and check my answer. Nice work. What is the next one? The next one says calculate the sample correlation coefficient. So I'm going to go ahead here. I will minimize this one so y'all can see. And if you look at it, my correlation coefficient, oops, wrong one. This is my correlation coefficient. My correlation coefficient goes right in this box right here. And they're asking me for 3 decimal places. So that's 0.977. So let me go ahead and plug that here. 0.977. And I will check my answer. Very good. And now they said describe the correlation. What kind of correlation is that? It's 0.977. So it's a strong positive correlation. Okay, very good. And what does it say? What is the correlation telling me? Aging causes number of words in the children's vocabulary to increase. As age increases, the number of words in the child's vocabulary tend to increase. As age increases, the number of words in the child's vocabulary tend to decrease. So please make sure, based on the correlation, there does not appear any linear relationship. So each and every word is very important. So you will go ahead and see, when I look at it, it says as the age increases, the number of words in the children's vocabulary tend to increase. And I will check my answer. That is fantastic.